Hey guys, are you ready with your copy and pen? Because this is day 10 of 100 days of DSA challenge, and today we are back with another medium level question 3439 reschedule meetings for maximum free time 1. Now, this question is not the one which you can just watch and understand. You actually have to use your brain and you have to question why I did the things I did. Okay? So this is going to take a while, so stay with me because this will probably be a long video because it took me some time to figure out the logic. All right, so let's not read all this and just get straight to the explanation of the question. So you are given event time. First, you are given event time equal 5. What does this mean? This means that whatever the event is, it is 5-hour long event. Okay, so it has 0 to 5 hours. Okay, and then k equal 1. What is k? K is the number of times we are allowed to reschedule an event. Okay, so basically this is the line you are given. This is the like a timeline. So it's a 5-hour event, so one of these rectangles represent an event within the a meeting within this event. Okay, so it's a 5-hour event, this is a 1-hour meeting, this is a 2-hour meeting. Okay, like that. And you are given start time and end time arrays. Now these arrays represent that when a specific meeting started and ended. So the size of these arrays represent the total number of meetings. So as you can see in this, there are 2 meetings, hence the size is 2. And the first element represent of start time represents the start time of the first meeting. So this meeting started at the first hour, and end times first element represents the ending of the first meeting. So for the first meeting started at 1 hour, first hour, and ended at second hour. So that is what it's meant here. Okay, so you can understand it better with the diagram. Similarly, the second meeting started at third hour and ended at fifth hour. Similarly in this. Okay, so now what you have to find out is that you have to reschedule k number of meetings, and you have to get maximum free time. So the target is to get maximum free time. So you can see in this question, in this particular test case, what I can visually see is that if I shift the first meeting either here or either here, then I will get 2 hours of free time. Okay, let's say I shifted the meeting here, then 0 to 2 is free. Or if I shifted this here, then 1 to 3rd is free. So I'll have 2 free hours. So hence the output for this is 2. That is what we have to return. Similarly in this, we are allowed to move only one. So I think we can move this one here and we will get like 3rd to 9. That is 6 hours of free time. So that is what we have to find out. Okay, so now let's start with the explanation. And guys, I'm telling you, go and try this question out after watching this video because you won't understand it if you don't do it yourself. Okay, so here I have this test case and let's see what our algorithm will be. So I would say that we have to reschedule the meetings, right? So these are the meetings we have to reschedule. Now what I'm saying is that instead of seeing that you have to reschedule the meetings, try to think of it as that when you reschedule a meeting, for example, if I reschedule it here, then what am I doing? I am rescheduling some gaps. Okay, I am rescheduling gaps. What did I just say? So if I am moving this here, let's identify the gaps first. What I mean by the gap is that you see this meeting is ending here and the next one is starting here. So the gap here is 9 minus 4. So that is what I'm referring to as gap. So how many gaps are there? There's gap number 1 here, gap number 2, gap number 3. So there are 3 gaps here. Alright. Now, what I'm saying is when we are shifting this, then how many gaps are we adding up? If I shifted this here, then this gap got here and this gap got added into this. Okay, so here the gap number 1 and gap number 2 combined. So before, here was gap of 1 hour and here was gap of 9 minus 4, 5 hours. After shifting it here, this will be a gap of 9 uh, 9 minus 3 of 6 hours. And what is 6? 6 is 5 plus 1. So when I am shifting one meeting, I am affecting 2 gaps. I am adding 2 gaps. So what is 2? 2 is basically k plus 1. What is k? K is the number of times we can shift a meat. So I can see that when I shift one meat, I am affecting two gaps. I am adding two gaps. Alright. So that is something that is clear to you now. Okay. So what our approach will be is that we will consider we will consider an array. Let's consider an array, and in this array let's record all the possible gaps which are in this particular schedule. So what is the first gap? The first gap, I would say, actually is the one which is here. In this case it is not here, but let's say if there was an event and it was starting at the first hour instead of the 0th hour, then this is a 1 hour gap. So it's important that we take this in our array. So this is our gaps array. The first gap is 0. What is the second gap? The second gap here is of 1 hour. What is the next gap? Next gap here was 5 hours. What is the next gap? See, there is one gap here too. Just like here, there is one gap here too. What if the meeting was what if the last event was ending at 7th hour, but our event was 10 hours long? Then this is our 3-hour gap. So we need to note this one too. Okay. So that is how we got the array of gaps. Now what we are going to do is we are going to use sliding window. So what am I going to do is I'm going to take the window size as k plus 1. Why k plus 1? Because I told you that at one time we are adding k plus 1 gaps. If I'm moving a meeting once, that means I'm adding two gaps. Okay, so that is creating a gap of this plus this. So that is why the window size will be 2. And I will just find out the max of consecutive elements in this array in the window. Okay, so let's say my window size was 2, which means k was 1. So I will first find out the sum of this. The sum of this is 1. Then I will find the sum of this. The sum of this is 6. Then I will find the sum of this. And the sum of this is 5. And I will find the maximum of these. What is the maximum? 6. And what was the answer that we had for this test case? It was 6. So this algorithm works for all these cases. Okay, I hope you all understood the algorithm. Now let's see how can we code that. Let's get an idea. So let's say k was 1 for us. Let's say k was 1. Then we know our window size is 2. Okay, so what I'm saying is that let's calculate the sum of the initial window first. So this is our initial window of size 2. Let's calculate the sum of it before we use the sliding window for the rest. Okay. So I am saying that this is our sum. So let's say this the sum of it is 2, and I am storing it in a variable. Now I am starting with my main loop. So what my main loop is doing is basically I'm taking a pointer I, okay, or a variable I, and I am initializing it with k plus 1. What is k here? 2. What is 2? K here is 1. So what is 1 plus 1? It is 2. And what is at index 2? 5. So now here it is our I. Now what we will do is we will move this I till the end of this loop. Okay, so for each in each iteration we are moving I by 1. So for now it is at I. So what I will do is simply I'll store it in a variable, and the next time in my main loop I will simply add the new element. So I add the element of I into our old sum. So that will be 7. But 7 is not the sum of these two, right? This is our current window. It's not the sum of these two. Why? Because this element is also being added in our sum. So what we also want is that we are subtracting the old element from it, so that we only know the sum of this window. All right. So what is this actually? So this is actually this is I. Okay. So it is I minus, what is k? K here is 1. So k plus 1. So that is how we will point towards this element. So for each iteration, my new sum will be old sum plus the element at I minus the element at this position, I minus k plus 1. Run this, like dry run this, and you will get it. Let's get to the coding part now. So I have taken a vector of integer type, named it gaps. Now what is this gaps dot pushback start time? So what I'm doing is I'm basically pushing the first gap, the gap from 0 to 1 into this. So why have I written this? Because it is at 1 that the meeting is starting, right? And how will we find the gap? The event starts at 0 and I have to find 0 to 1. So I will simply write 1 minus 0, or I can just simply write this. Okay, and then I've taken a loop from I to start time size minus 1. So this is a start time. Okay, I've taken it for size minus 1. That means it will only run till this element. It won't run for this. It will only run for this element. In this case it will only run for these two elements, not for this. Okay, so for this our we'll push start times I minus 1 minus end time I. Now what does this mean? Okay, so think that what does a gap mean? What does a gap between two meetings mean? It means it means the difference of the starting time of a new meeting and the ending time of the current meeting. Okay, so if the current meeting ends at 2 and the next meeting starts at 3, I know that the gap between them is 3 minus 2 1. So that is what I've written here: start times next start time minus the current meeting's ending time. And after I'm done with this, I'm pushing again into this array vector event time minus end time size minus 1. Now what does this mean? This is basically to add the gap of this. So if the event was ending after, like, let's say the total event time was 6 hours in this one case, and the last meeting ends at 5, then there's a difference between 5 and 6, right? So to cater to that difference, I've written this one to basically push the last gap into this, sorry, this one, right? Now after this our gaps is done, the gaps array is done. Now let's see how we can write the main logic. So let's say there's a variable current sum. It is currently 0, and this is to calculate the sum of the first window. And now I've taken a variable max, which is our final answer, which is the maximum gap, and it is equal to the current sum. Now why have I initialized it with current sum and not with 0? Because in the logic later I am comparing the max, I am finding the max after manipulating the current sum. So I am doing it after changing something in the current sum. So if I do that, if I initialize max with 0, then the sum of the first window will never be considered in our final answer. Hence, I have to make sure that it is considered in the final answer. If it is greater than all the rest of the sums, then it should be considered. That is why I have written it. I have initialized max with that. Now I have written for I equal k plus 1. I explained it in the explanation earlier. I less than gaps dot size I plus plus. Current sum is equal to gaps ith element minus the old element I told you, and then we simply find the max at each iteration and we return the max. And this code is accepted at 100% beats, 0 millisecond runtime. So thank you guys for watching, and I'll see you on day 11.